Hello, in this video we will discuss about finite state machine and behavior trees. This video will be explained by Yeni, Riska, Pratiwi, yang delila, salsabila, and dede saputra. This is table of content. For finite state machine, we will discuss about the description, the concept, the composition, and application. We doing the same thing with behavior trees. Then we will compare between finite state machine and behavior trees, and we got the conclusion. Okay, let's start about finite state machine first. Description: finite state machine can be one of a finite number of states at any moment. It means countable. Unfinite is uncountable, so finite means countable. Finite state machine move from one state to another based on input. So, base you can have a number different state. Finite state machine might just take an input, so can produce an output. Concept: finite state machine is an abstract model for understanding circuit. In all finite state machine, there are discrete number of states. Chain of states are triggered by transition, and it can only exist in one state at a time. Composition: the very basic idea is ballpoint pen. This can be example of finite state machine. The state is a ballpoint extended or ballpoint retracted. The input is click the ballpoint button, and the output is extending and retracting ballpoint. This can be represented become STD or state transition diagram. Here is a state transition diagram of the ballpoint pen. The zero state is represented by ballpoint retracted. The state 1 is represented by ballpoint extended. The arrow represented the transition between state. The arrow includes input. So in this case, the button is clicked and moved from state 0 to state 1. We give the same thing input and it will be back again. We also can use state transition table. This table model the input, the current state, and the next state. We can see here, if current state ballpoint retracted, we need provide input button clicked, and the next state is ballpoint extended. And if current state ballpoint extended, we need provide input button clicked, and the next state is ballpoint retracted. Application: application of finite state machine first is traffic light. It has 3 states. There are red, green, and amber or yellow. The second is vending machine. Is a dispense product when correct payment is given. And the third is elevator to ensure people to get dropped off at higher floors before it returns down.
Okay, in this change I will explain about behavior trees. So, what is a behavior tree? A behavior tree is a mathematical model of plan execution used in computer science, robotics, control systems, and video games. They describe switching between a finite set of tasks in modular fashion. Their strength comes from their ability to create very complex tasks composed of simple tasks, without worrying how the simple tasks are implemented. Behavior trees present some similarities to hierarchical state machines, with the key difference that the main building block of a behavior is a task rather than a state. And a behavior tree is graphical that presents as a directory in which the nodes are classified as root, control flow nodes, or execution nodes or tasks. For each pair of connected nodes, the outgoing node is called parent and the incoming node is called child. The root has no parents and exactly one child. The control flow nodes have one parent and at least one child. And the execution nodes have one parent and no children. Graphically, the children of control flow node are placed below it, in order from left to right. And next, this is the concept directory of behavior tree. There are 2. First, control node, and second is execution node. The execution of a behavior tree starts from the root which sends ticks with a certain frequency to each child. A tick is an enabling signal that allows the executions of a child. When the execution of a node in the behavior tree is allowed, it's returned to the parent a status running if its execution has not finished yet. Success if it has achieved its goal, or failure otherwise. So, execution nodes, which are leaves of the BT, can either be action or condition nodes. The only difference is that condition nodes can only return success or failure within a single tick, whereas action nodes can span multiple ticks and can return running until they reach a terminal state. And the control nodes are internal nodes and define how to traverse the BT given to status of their children. Importantly, children of control nodes can be execution nodes or control nodes themselves. Sequence, fallbacks, and parallel nodes can have any number of children, but differ in how the process set children. Decorator nodes necessarily have one child and modify its behavior with some custom-defined policy. Okay, in next section is compositions of direct tree or behavior tree. Check out of the image below to see how different control nodes work. First, sequence nodes execute children in order until one child returns failure or all children return success. Fallback node execute children in order until one of them returns success or all children return failure. These nodes are key in designing recovery behaviors for your autonomous agents. The third, parallel nodes will execute all their children in parallel. This is in quotes because it's not true parallelism. At each tick, each child node will individually tick in order. And parallel nodes return success when at least and child nodes or between 1 and n have succeeded, and failure when all child nodes have failed. The last is decorator. Decorator nodes modify a single child node with a custom policy. A decorator has its own set of rules for changing the status of the decorated node. For example, an invert or decorator will change status about success to failure and vice versa. While decorator can add flexibility to your behavior tree arsenal, you should take to standard control nodes and common decorator as much as possible so others can easily understand your design. Okay, next, the application of Pac-Man game. This is one example or implementations about behavior tree. There is a Pac-Man games. Behavior trees are commonly used in video games for implementing the non-player characters or NPC, and also in robotics. And BTAs or BT are able to solve complex problems such as Pac-Man videos that we can learn before.
Introduce myself, my name is Dede Saputra, my name is K221 I will to next presentation. In this slide, finite state machine versus behavior trees. As simply, behavior trees have a few advantages of finite state machine. They provide lots of flexibility, are very powerful, and they are really easy to make checks to. With that said, behavior trees and finite state machine don't have to be mutually exclusive. Behavior trees can describe the flow of the AI, while the finite state machine describes the function. This combination gives you the power of behavior trees while still having the functionality of finite state machine. Next, conclusion. Conclusion. This one is behavior trees and finite state machine don't have to be mutually exclusive. Behavior tree can describe the flow of the AI while the finite state machine describes the function. 2. This combination gives you the power of behavior tree while still having the functionality of finite state machine. Thank you.